The Center for Nanophase Materials Sciences, the CNMS, is a user facility that's established by the Department of Energy's Office of Science to provide the resources that users need for their work in nanoscience. Interestingly, a lot of the properties that are needed for batteries, for photovoltaics, they all rely on mechanisms that happen at the nanoscale. And our goal is to use these properties to create new materials that can be used to address our energy challenges. There are 5 DOE nanoscale science research centers across the country, and of course each one has a slightly different emphasis. All of them have a combination of synthesis, of characterization, fabrication, and theory, but each one benefits from a specific environment. We are close to ORNL computing resources and to the neutron sources, and we tie very closely to the work done with neutrons. And we do this as a user facility, so we make the resources available so that users can come here and perform their work, and we can provide the expertise that they need to create their research.
The Nanofabrication Research Laboratory at CNMS is a fully functioning cleanroom facility where we have a unique suite of tools to develop nanoscience research for our users all the way from concept to device level. We have a suite of tools that are unique to the cleanroom that allow us to do both 2D and 3D nanofabrication, all the way from nano to microscale devices, where we can incorporate things like 2D materials into device level and tune their functionality to create nanofluidics for nanobio-inspired research. CNMS is a unique facility where we can not only create structures that we are interested in studying on demand, but have full capacity to investigate those structures from their mechanical, physical, and chemical properties directly at the CNMS and tune our processes for creating these structures through the feedback loop of studying their properties. So we have a full life cycle for understanding from concept to creation to tuning of the device in-house, allowing research to be carried on in a full life cycle.
At the CNMS, we're developing new techniques in microscopy, and what we do is actually develop new techniques for scanning probe microscopes. So we can scan across the surface with this sharp point, like you'd imagine a record player, and we can measure the shape of the surface, and depending on the vibration of the cantilever, we can get material properties, and we can also get electrical properties as well at the same time, and a host of other important properties. At the CNMS, we have one of the most advanced fleets of scanning probe microscopes, and we also have developed some of the most advanced techniques on these microscopes. And so when users come to the CNMS, they have access to all of these techniques, they have access to the experts who invented these techniques, so we can really help them to characterize and understand their materials at a whole new level.
Atom probe tomography is a nanoanalytical tool which provides 3-dimensional imaging and composition measurement at nanometric scale. This is the only technique which provides both compared to other techniques. So what we do is we make a sample which is like a sharp needle and then provide a voltage, and those voltages are pretty high, like 5 to 20 kV, and at that time we ionize the surface atoms and then we apply a voltage pulse or laser pulse, and it triggers the ionization. So my main aim for my research is to solve complex material related problems using atom probe. Currently I'm working on energy storage materials like lithium-ion batteries, gallium nitride based heterostructures which are semiconductor layers for power electronics application and optoelectronics application, and also some thermoelectric material. These are very new material for atom probe tomography.
I use cell-free systems in order to investigate spatial dynamics in gene expression. Effects like macromolecular crowding and confinement are difficult to investigate using cells, so I use the fabrication resources at the CNMS to make microfluidic devices which allow me to more rigorously analyze those macromolecular effects. It's extremely unique to see so many resources all in the same facility, and it's even more unique to have so many different people willing to help you with those resources.
Well, the main focus of my research at CNMS is try to push the frontiers of electron microscopy, and particularly the electron energy losses spectroscopy. Basically what I'm trying to do is I'm trying to use the electron probe, the electron microscope, in order to do measurements that had never been done possible before. And in the way that I do that is by manipulating something that is called the phase of the electron in order to be able to have get signals from the electron microscope with atomic resolution that were not possible before, as a magnetism. The idea is that when we try to, for instance, push the frontiers of electron spectroscopy or electron energy loss spectroscopy in the electron microscope, it is not just something that it will be for the community within Oak Ridge, but it will be able to the users that come here will be able to do measurements that had never been done possible before, and they will be able to do experiments that they were not thought that they were possible before.
There are just too many combinations of materials, composition, structures to try them all experimentally. Fortunately, computational approaches have gotten to a point where it will become possible to predict the properties of material before it has been synthesized.
The main goal of my research is to make realistic simulations of condensed matter materials, and for this purpose I'm mainly using something which is called density functional theory. That's a very well-known and powerful theory. That means that me and also my colleagues here at the CNMS can easily give theoretical support to experimental users here. There is a great amount of experience with the computational resources of the Oak Ridge Leadership Facility, and that offers another great opportunity for users to benefit from this expertise and to implement high-performance computing in their research.
We are very comprehensive. We offer things from the simplest equipment to the most complex instrument, and they're all available and they can be used in combination, and it's one single proposal that gets people in here to use all of those capabilities. Most users, once they come here, are surprised by just how much can be done here, and I would just encourage people to come and check us out and explore what is actually possible at CNMS.